Hey everyone, welcome to the show. This is my grade 11 section. We're going to be running through the syllabus. This is episode 1. And let's get into it. So, we're going to be starting off with a little revision. Exponents and surds. So, remember we have our number system, how we categorize numbers. And in grade 11, we're going to be expanding it a little. So, this circle over here, this is the work we did before. If you wanna just have an update on that, you can check out my grade 10 episode 1 video that I go into much more detail on what all of these terms mean. And yeah, before continuing, be sure to check that out if you still not sure what the integer is, a rational number or irrational number. And yeah, right, so from there we add two more groups. This is our real numbers and our non-real numbers. So from our definition, we see here that real numbers include all rational and irrational numbers. So we're just compiling these basically, and so everything here are real numbers. And non-real numbers is or imaginary numbers, because they are not real, which is imaginary, are numbers that, well, how do I best explain? They pretty much first believe that they don't exist, right? That's why imaginary they do not exist. But eventually they found uses for them, which I don't have to go through here. It's like, if you decide to continue with math after high school, they'll dive much more into it. But these are numbers that have square root negatives, which are, forbidden numbers. We don't talk about them. We hide them in a corner. We don't even want to look at them. And those fall into our non-real numbers. So if you see a square root negative answer, normally if you doing a sum or a question and you get a negative square root, chances are you did a mistake, or there's no solution to that sum or equation. Right. So just sticking with more revision, we're going to do some laws of exponents. You guys should know this, but hey, if you don't know and you somehow made it to grade 11, congrats, I guess. But it's going to end up hurting you more. So we have our a, this will be our base. This is just a normal number that we labeled a, and n is our exponent, and that just basically means a multiplied by a n times. So if we look at an example, we have the number 2, which in this case would be our a. 2 is our a, and n would be 4, because you see that we have 1, 2, 3, 4 n's. So that another way of writing 2 times 2 times 2 times 2 times 2 is 2 to the 4. And this happens with any other number as well, like even decimal numbers like 0.71 times 0.71 times 0.71 is the same thing as 0.71 cubed, or to the power of 3. And these are just more examples. And 501 squared is the same as 501 times 501. Right. Two more revision rules, I guess, or laws. If we have a base number to the power of 0, that will give us 1. So yeah, I'm gonna leave this up to you. If you can define this in the comments, I know how to do it. Obviously I know everything, but this a normal number raised to the power of 0 is 1 for all cases except when a is 0, because 0 to the 0 is undefined, right? And the second one, a to the negative n, notice over here that our exponent is now negative. We can write that as 1 over a to the n. So this whole term here just goes to the denominator. And the same thing applies. A cannot be 0 because 1 divided by 0 is undefined, right? Right, so here's some examples. So the first one is 5 to the minus 2. So using this rule over here, we see that we're just going to write 5 over 2 in the denominator, and then 5 squared is just 25, so our final answer is 1 over 25. Right, that's the simplest form. Okay, so we have second example is minus 36 to the power of 0 times x. from our first one over there, we see that anything to the power of 0 besides 0 is 1. So then we have 1 multiplied by x, and we know that anything multiplied by 1 is the same thing. So we have 1 times x, which is just x. And then third example, 7p to the minus 1 all over q3t to the minus 2. So we see that this negative exponent, so what we're just going to do, we're going to move p to our denominator, and then notice the t here. Now the t squared would normally go to the denominator, so if we just wrote it out, so I'll just show you how we get to that point. So we have 7. So yeah, I'm just gonna move the p already to the bottom, and then with the q is already there, and then this part here is gonna go to the denominator, the t squared. Right, now you see this over here doesn't look very nice. Besides my handwriting, that's also not very nice. We notice that we have a fraction and another fraction, but we also know that this is a divide sign, which is just the same thing as 7 divided by b q to 3 divided by t squared, right? So the thing with this divide is a rule that you should know, that you can convert this to a multiplication, and when you do that, you just invert the fraction, so it becomes t squared over p q cubed, right? So 3 over there. So, and then over here, this is still just over 1, and then we just multiply rules of fractions, and this becomes 7t squared over p q to the 3. So you see, that's how they got from that step to that step. So another way of just remembering it, a to the, when your exponent has a negative, you move it to your denominator, but if it's in your denominator again, already, you can just move it straight away to your exponent, right? Moving on. I hope you guys all understand. If you don't, tough. I'm joking, of course. If you don't, just you come and watch the video again, obviously. Duh. Right, so we use the following laws for working with exponents, right? So this should still be a revision. So we have a to the m times a to the n. So we know when we have the same base and we multiply our exponents, when we multiply our terms, we add our exponents. Let me get that straight again. When we have the same base and we multiply two numbers that are both exponents, we add our exponents, right? And the same thing applies when we divide, but we minus our exponents. So you see that these two are pretty much the same thing, just that's multiply and that's divide, and it's add and subtract. So let's say, for instance, we add a to the m multiplied by a to the minus n, right? So we see that those exponents are negative, so we can just apply our same rule here and then convert that into a to the m multiplied by our exponent a to the n. You see that minus exponent converted this to a fraction, 1 over a to the n, and from there, same as this here before, we just multiply our fraction, so we have a to the m divided by a to the n. So you see that we multiply these bases, which we would normally just add our exponents, but because this one was negative, this became a fraction and this became like a divide. So now we can apply this rule over here, our second rule, and we know that if we are dividing with the same base, that we can just multiply, we just subtract our exponents, so we're left with a m minus n, right? So you see, if this was negative here, then this rule which is just a m plus, but now that you see, if we made it negative, it will become negative n, and then if we multiply this out, the positive times the negative is a negative, so we have a m minus n. So you see how we use the same rules, like yeah, in this case we just use the first rule, and in this case we use the second rule, so it gave us the same thing, which is what we started with and ended with the same thing, right? Third rule, if we have exponent on the outside of a bracket, we just multiply it in, right? Each term, these two are pretty much the same thing. Each term in our parentheses or brackets, whatever you like to call it, is affected by our exponent. And a good way to always is to check this on a calculator. So if you had 2 times 3 to the power of 4, just 2 to the 4 times 3 to the 4, and then same thing, right? And then this last one is we have exponent on the outside, but our term on the inside also has the exponent. Then in this case we multiply exponent. You see, this is the only case where we multiply exponents together. Like when there's no bracket involved, it's always just adding or subtracting. Alright, and for all these terms, a is positive, or more than 0, p is more than 0, and m are integers, right? Cool. So simplify the following. We have 5 into m 2n close bracket p times 2. It's a long stuff, eh? And there's a lot of unknowns, but we're just going to simplify it. So what we're going to do, we're just going to follow our rules. So what we're going to do, we're going to do our brackets first with our exponent. Excuse me. So we're going to use this rule over here. So we're going to be left with 5. It says on the outside for so long, m 2t, but remember this is on the outside of our bracket, so we're going to multiply p multiplied by 2 m, there's a bracket over there, 3p multiplied by t close bracket, so that becomes 5. Do this very slowly, not going to skip any steps. M, so this becomes 2tp multiplied by 2m 3, let's try the same, tp. So now we're going to multiply our coefficient inside, so this just becomes 5m 2tp. Amazing handwriting. Multiplied by 2m 3tp, which equals to, and notice over here we see that our bases are the same because they both have m, the unknowns are both the same, but you see that our coefficients are different, but we're multiplying. If this was an add, we wouldn't be able to add them, right? But since we find the product of the two, we can say that 5 multiplied by 2 is 10, right? And then our basis stays the same, and notice our exponents, because we're doing this rule over here, we can be adding our exponents, so we have 2tp plus 3tp, and that equals to 10 m to the power of 5 tp. Great handwriting there, great stuff. But you get the idea, right? Righto. So second question, we have 3 multiplied by 3b close bracket to the power of a. So what we're going to do, same thing again, we're going to do our exponent first. So we know in this exponents we multiply, so it's going to be a multiplied by b, which is going to give us ab. and then from here we know that our parentheses or brackets is multiplied. So I'm just going to write it out, which is 3 multiplied by 3 AB. So and then notice here we have same base. If we have the same base, different exponents, we add the exponents, so we're left with 3 is AB plus 1. Why is it plus 1? Because if we know there's nothing there, that is the same as 1. So that's where the 1 comes from. Right. Quick stuff, quick stuff. So, next question we have a nice simplify. So, yeah, let's jump straight into it. So, this should still be a revision for you for the grade 11. So, there's technically still grade 10 work. I don't think the grade 10s are here yet. They're still doing other stuff. Right. So, we have 3m over minus 3m, 3 to the power of m minus 3 to the power of m plus 1 all over 4 multiplied by 3 to the m minus 3 to the m. Right, so so we have, this is all one sum, but in our numerator we have two terms. We have our 3 to the m, and our second term is minus 3 to the m plus 1, and at our denominator we as well have two terms. The 4 multiplied by 3 to the m, and our second term is minus 3 to the m. So, what do we do first? This is what we do. Notice how we have a common factor in both our numerator and denominator, which is 3 to the m, right? So you should know how to take out a common factor. So 3 to the m, we take this out, we're going to be left with 1 minus, remember this plus 1, remember from this example, you see that plus 1 is just a 3 on its own, right? So if we're going to take 3 to the m out of it, we're still going to be left with a 3 by itself. So we're going to be left with minus 3, right? And if notice, if you multiply this back in, you're going to be left with the same thing here. That's what factorization is. So we're going to do the same thing over here, but we're going to take out 3m as well. So 3m, and then once you take this left, we're going to have that 1 over there, but then it's going to be 1 times 4, so we're just going to be left with 4, right? And on our second term, we're going to have a minus there, because we can take our minus out, and 3m, remember, it's just 1, right? Cool. So remember, this is simplifying. It's not solving x, it's not an equation, so we can cancel out the unknowns. So those two cancel. 3m over 3m is just 1, right? So we left with 1 over 1 minus 3, which is just minus 2. Check on your calculator if you don't believe me. And we're going to have 4 minus 1, which is this 3. So our final answer is minus 2 over 3. Right, next part. So everything up until here has just been revision, and I really don't want to make this video too long, but let's just jump into the first part of how we grade 11 work. So we have rational exponents and surds, basically the same thing. So surds, what are surds? Surds are these little square roots over here. Alright, so let's consider this first part. If r to the n is equal to a, then r is equal to the nth root of a. Alright, so and n has to be more than 2. You've actually been working with this for much longer than you think, because let's say someone gave us x squared is equal to 4, right? How would you solve this? You would take the square root of both sides, right? And when you did that, you'll be left with x is equal to 2, right? So this is exactly what's being done here. They're saying that just in our example, our x is r now, and n is 2. So, and a is 4. So it's basically that's what we've been doing the whole time. And then these are just expanding on that same premise. So we see that these are just writing the same term in a different form, in a third form. So over here we have a to the fraction, or our, in this case our exponent is a fraction or rational. It's what our subject is called, our topic. So what we're going to do, we're just going to write it in third form. So a to the 1 over n is just the nth root of a. So these two are equal to each other. It's the equal sign. Right, and then our other rules are the same. We have a to the negative 1 over n, which is just the same as a to the minus 1 times n. Because remember our rules of exponents, we're just moving back a step, and then we're just converting this whole thing into our nth root. And then remember that a to the minus 1 is just 1 over a. See how they got from there to there? And then let's say now in this case we had a to the m over n. This m is still part of our a, which we just leave over there. So it didn't really affect anything. Right. So let's do a quick example. Simplify without the use of a calculator. Right, we're not going to be using calculator for this one. So we have, notice I want to start very easy, so I didn't add any unknowns or variables. I just used 5, 4, 9. Right. So first thing we're gonna do, we're gonna convert this negative exponents. So we're gonna be left with that 5 stays unchanged, and 4 to the minus 1 is just 1 over 4, minus 9 to the minus 1 is just 1 over 9, all to the power of a half. Right, and then over here in our denominator we can simplify that even further by finding a lowest common denominator. So the 5 still stays over there. 4 and 9 is 36. So to get 4 to 36, we multiply it 36. What is that? 9 times. Duh. And then the negative over there stays there, and then this becomes 4 to the power of half, and then 5 minus 4 is 5. Notice 5, that's equal to 5 all over 5 divided by 36 to the power of half. And then we can remember this fraction is just the same as divide, so we're gonna have 5 divided by 5 over 36 to the power of half. This we can write in a form of multiplication, so it becomes 5 multiplied by 36 over 5 to the power of a half. These 5's cancel. These 5's cancel, so we're left with 36 to the power of a half. And remember from our rules that we just said that 36, we're just going to convert this from half. Remember, this is our n over here. This becomes square root of 36 to the, you see, normally we write the value of the n over there, but square roots basically is 2 over there, and then we know that the square root of 36 is 6. That is our final answer. So just one thing before I leave you, we know that the square root of 4 is the same thing as 4 to the power of half. Do you see that we do not write 2 over there? So that means that that value is normally 2. But if it was not, if it was something else like 3, and then this would be 4 to the power of, that's right, 1 over 3. Cool. Thanks for watching. This was mostly just revision. Yeah, I'll be trying to get this videos out once a week. I've really been busy with my other stuff, you know. But yeah, see you soon. Bye.